This video is to help you with section 6.2.2. We'll be using the distributive property to solve equations and check solutions. So it says sometimes a lot can depend on the solution of a problem. For example, when businesses calculate the cost of packaging and shipping a product, they need to come up with an accurate value. If they miscalculate by only 1 cent per package, but ship 1 million packages per year, this small miscalculation could be costly. Solving a problem is one challenge. However, once it's solved, it's important to have ways to know whether the solution you found is correct. In this lesson, you'll be solving equations and finding ways to determine whether your solution makes the equation true. So they're starting with 660. I'm thinking of a number. If you add 2 to the number, then triple it, you get 9. And they want you to build it on the equation mat using the algebra tiles. So when they say I'm thinking of a number, you're going to basically use a X tile because that's representing your unknown number. So let me make that a black X tile so that it's positive. Okay. So this is representing our unknown number, or X. If you add 2 to that number, which means that you're adding 2 unit tiles, okay, and then triple it, you're going to get 9. So right now we have the thinking of a number, adding 2 to it. Now for tripling it, we're going to need to basically make this 3 times as much. So we're going to end up with 3 X tiles, and we're going to end up with 6 of the unit tiles because we're tripling it. So in essence, we are moving these here now so we can see 3 groups of X plus 2. And on the other side of the equation, or on the other side of the equation mat, we are basically going to need to have 9. So we're going to have 9 of these. Okay. So when you build the equation, it's going to look something like this using your algebra tiles. So right now I have this. I need a couple more to make a total of 9. So something like this. All right, so then 2 ways to write this equation. Well, one way to write it would be to think of it as 3 groups of X plus 2. So in other words, we could write it with parentheses. 3 times the quantity X plus 2 equals 9. And we may want to make that print size a little bit smaller, so I'll do that for you. And the other way to think of it would be to look at it as the entire thing on the left side, which would be 3x plus 6 equals 9. So in other words, we're writing it in factored form, and we're writing it when we've used the distributive property and multiplied each term inside this parentheses by 3. And then as far as solving it goes, we would first start by looking for any 0 pairs, which we don't have any. We'll leave it in this format for now. And then we can remove things from both sides, again, as long as we can do it to both sides. So we can remove 6 unit tiles from this side, as long as we can also remove 6 unit tiles from this side. So I guess I'll just put them off over here. Okay. So once we've done that, we're basically going to have 3x equaling 3. Now, as far as the showing your work goes, what I'm going to want you to do is to show that you subtracted 6 or took away 6 from both sides. I want you to show it in that way. Okay. Then I like to put a line below it, say, okay, what do I have now that I've subtracted 6 from both sides? What do I now have being shown on my mat, which is 3x equaling 3. And then, of course, if 3x equals 3, that means that we can make into 3 groups. So we can say, all right, we don't want 3x, we want just 1x. So we're going to divide that into 3 groups. And dividing it into 3 groups would be shown algebraically by showing that we're dividing by 3 here and here. This is the way we would show our work for that. And then what we'd have would be that x would equal 1. Okay. because when we divide in 3 groups here, we have x. When we divide in 3 groups here, we have 1 in each group. The way that they want you to check your solution would be to write down the original equation. We can write the 3x plus 6 equals 9, or the 3 times the quantity x plus 2 equals 9, either one. And then we're going to replace x with what we believe x is, which is, we said 1. So in place of x, we're going to replace it with 1. And then as far as work goes, 3 times 1 plus 6, of course, is 9. 9 would equal 9. And then we show a check mark to indicate that we have checked it and that it comes out correctly. If the left side equals the right side, then we have proven that our solution is correct. We have proven that we've checked our equation and that it does meet the requirements. It does satisfy the initial equation or statement. Right? You're going to do the same concept for 661. You have 4 groups of x plus 3 equal to 8. You're going to build it on your equation mat. Go ahead and solve it and show your steps, and then also check your equation, check your answer. Okay. For 662, they remind you that if you solve an equation that has a solution, you get a value for the variable. How do you know that you've done the steps correctly and your answer works? Again, the idea is that you can put in your value of x into the original equation and prove that when you take, in this case, 4 times the quantity x plus 3, it does indeed equal 8. In other words, look at your answer that you just got here and replace x with what you feel x is once you've solved it, and then based on that, prove that 4 times the quantity x plus 3 does equal 8 by showing your steps and showing your check. 662, they are having you look at Kelly's work and Madison's work. So they both started out with the same equation, but Kelly got a solution of x equal to 2, and Madison got a solution of x equal to -1. So what they did is they went back to the original equation, and in place of x, Kelly put 2. And so she put it here and here because there's an x on the left side and an x on the right side of the equation. That can occur. Madison thought that x equaled -1, so she replaced x with -1 here and here. And then what they're saying is with this equal sign and a question mark is the left side equal to the right side? So if you take 2 times 2 minus 7, does that equal -2 times 2 plus 1? So you can put this into a calculator or you can figure out the value yourself. But 2 times 2 minus 7, what does that equal? -2 times 2 plus 1, what does that equal? If they are equal to each other, you put a check mark behind them and you say, yes, Kelly had the correct answer. If not, then she did not. Same thing with Madison. You take 2 times -1 minus 7, see what that equals. -2 times -1 plus 1, see what that equals. Does the left side equal the right side? If it does, you put a check and Madison's correct. If not, then she is incorrect. Okay, so you want to decide if either girl has the correct solution. All right. They also go through with you then some steps again that you can use and how you can show that. Now you'll notice that they're showing that they're subtracting 3 from both sides of the equation by showing it this way. In other words, they're doing it all within the same line. That is another way to show that. More typically, though, in our classes, we prefer you show it this way. So you put it beneath it and then show that. But sometimes you'll see different teachers show it this way as well. All right. And then 664 is basically just practicing these. You're going to be solving them and showing your work, recording your steps, and checking your solution. So if you get stuck on any of those, please let me know.